friends, in today's presentation I'll be performing electroplating. I'll be using a solution of copper sulphate. I'll be using a lot of electrodes. I'll be using graphite electrode. I'll also be using carbon electrodes. I'll be using iron electrodes, but I'm going to be electroplating a nail. For this project, I have the nails, I have the carbon electrodes, I have copper sulphate, I have a 12-volt battery here, and I have distilled water here, and we'll also be getting our electrodes from this lithium-ion battery. Our carbon electrodes we've gotten from this lithium-ion battery. So, if you open one of these lithium-ion batteries, you should be seeing a roll folded like this. Of course, this is copper. You can wash it neatly. So that's the way to get copper. So this is it. This is the copper electrode. Okay, I'm going to use this for this particular demonstration. Alright, so but first of all, what is electrolysis? Electrolysis is the decomposition of a substance by passing direct current into it. It must be direct current and not alternating current. Alright, so what is then electroplating? What the aim of today's project? So electroplating is the covering of a metal with another metal to protect it against corrosion or to protect it against rusting, to give it a good appearance. Or this process will also be done to purify a particular metal as well. Alright, so we get started with the process. So the first thing I'm going to do is to pour some distilled water into this beaker here. Then I will be adding some copper sulphate crystals to it. Okay. So I'm using a plastic spoon. Alright. Okay. I will stir this mixture. I will stir this solution. Okay. So that's it. Okay. Alright. Okay. So we get started. So for my electrodes, I'm going to use these are crocodile clips related to wire. Okay. So I have the copper electrodes. Like I said earlier, the copper electrodes got it from here. This copper sheet got it from here, from this lithium-ion battery. So I'm going to fold it. I'm going to fold it. I'm folding it neatly. So I've gotten my copper electrode. I'll put a hole, tiny hole into it. Alright, so this copper electrode is going to go to the positive terminal. Tie it into it. Okay. Then without the battery. Okay. So the negative part of this battery, which is the cathode, goes to this iron nail. This iron nail is a clean iron nail. It has been sandpapered. Okay. I make sure that both electrodes are not in contact. Alright, so it has started working. So let me take my meter and read the voltage drop Okay, so let me read the voltage drop. 5 point, okay, it's actually 6, it's actually fluctuating. Yes, 7.2 volts, that's the voltage drop, okay, for this particular cell. The nail to be electroplated is the cathode, while the copper electrode is the positive terminal of the battery, which is the anode of the electrolytic cell. You can see it. This brownish substance here. Alright, so let me dip it back. I can also see this copper part. Okay, it's eating up. The copper anode is eating up. Gradually, you can see the color. And let me just allow it to go for some time. Let's see our results again. So you can see this the brownish copper metal on top of this nail. Let us keep this one aside. You can see it very clearly. So it has manipulated this particular nail. Let's try another nail. Let me keep this one here. Let me try another nail, another clean nail. Okay, let me try this one. I'm going to attach this one. See, this is very clean. Look at it, just changed immediately. Okay, it has coated it. It has formed a layer of copper on top of this nail. Let us explain what's going on. But first of all, it has electroplated. So this is a layer of copper on top of this nail. I have electroplated it, and this one looks beautiful. This one looks better than the other one. Alright, so let's explain what is happening here. Here we have the copper ions and the sulphate ions. Okay, because they are negative ions, they move towards the positive ions, and for the negative ions, which happen to be for the positive ions, which happen to be the hydrogen and the copper ions, they move to the cathode side. And because hydrogen is higher than copper in the reactivity series, copper is discharged. So copper is on top of this particular electrode. Then for this, you can see that it's going into solution. So oxidation takes place, and the copper here goes into solution. Copper is eating up. You can see it's eating up. It goes into solution. It is oxidized, while reduction occurs at the cathode, where it gains electrons and forms a layer of copper on the nail. Alright, so I'm going to use inert electrodes. I'm going to use copper electrodes. So in place of this iron electrode, I'm going to use carbon electrodes. Alright. Okay, so it didn't take up to a minute. Well, let's look at this electrodes. Let's look at this graphite electrodes. From this, you can see the copper electrode right on top of it. Okay, copper electrode is right on top of this graphite electrode. So, okay, let's still go. Now, let me change this one. Okay, let me replace this graphite. See, it has coated it with copper. It has copper on top of it. So copper comes out of solution. Copper is discharged with the use of an inert cathode, which happens to be graphite. Let us still look at it's heating up, showing that copper is going into solution. Okay, here at the anode we have oxidation reaction. Okay, oxidation reaction is taking place. The metal is heating up, and here we are seeing the deposition of copper on the surface of this graphite rod. Okay, so because hydrogen and copper comes to this electrode, but because hydrogen is higher than copper in the reactivity series, copper is discharged, that is, copper is liberated, copper comes out of the solution. Right, so for this goes into solution. Here, oxygen is liberated at the anode, oxygen is liberated. So in this other part of the experiment, I'll be using graphite rod for the anode. The anode is the positive side, while the cathode is the negative side. So let's see the results. Okay, let's observe the results. Here there are real bubbles. Bubbles are coming. So the process is almost the same, except for the anodic graphite. It's inert. It doesn't go. It's not going into solution. Okay. So at the anode, oxidation is occurring, while at the cathode, reduction is occurring. Shortly, we will definitely see the coating. Look at it. It didn't take much time. So this time around, we are using graphite electrodes. See? Look at it. Okay. So it has coated it very, very well. Alright, so let me try a nail and a very thin nail, and so I'm going to replace this. Okay, copper was deposited there. Let me use this. Let's see the reaction. Let's see what happened. You can see it coated it very well. So we have a copper here. This was the copper anode we were using at first. It entered into solution. It's okay. So let's bring this nail out. Look at what happened to this nail. Let me still put it on. So what is happening is that here oxidation at the anode, reduction at the cathode. Copper is being discharged from solution. Okay, so copper is coating. So this time around is graphite and iron electrodes. Of course, we can see the copper coating of the iron nail. Okay, copper is coating the iron nail, and nothing is happening to this. Just nothing is happening. Alright, so put it back. Nothing is happening to the anode. No reduction of mass. start eating up. Let's observe. Okay, so this is it. This is it again. Okay, copper coating. And so that is a project on electrolysis of the copper sulphate. That's a project on electroplating using copper sulphate. I hope you enjoyed it. Thank you for watching. Till see you in another video. Thank you.